Okay. May I call a volunteer to lead us in prayer, and then we start. Others will get us on the way. Volunteer, please. Makula, thank you. Open your mic.
Let's embrace a side of prayer. Heavenly Father, given us one thing for blessing and protecting us. Heavenly Father, put the lesson into your hands. May we please be able to understand everything that's going to be told. In the name of praise. Amen.
Amen. Thank you very much. Now I'm going to request you to mute. I want to mute you, but I'm going to request you to mute. I hope you can get me. I'm also going to request that you mute both the audio and the video. Let us be brave. And continue. I think that will be a good practice. Thank you very much. Okay, I want us, like you tested there, to discuss complex numbers, which we already know. Now, may I request someone to, I don't know whether I can get my screen. What is on my screen, if someone can get it? Can you see my screen? I just want to know what is on my screen.
So we can see your screen.
What is on it?
A white page. Or I think it's wide. I don't know.
Okay. It's a white page. Okay, let me share a small thing and someone can read for us. Okay. Anyone ready to read for us?
Imaginary numbers.
Please put up your hand. Just civilized. Put up your hand. Yes, Semakula. Do we know how to put up our hands? I hope so. Okay, Semakula now is there. Please read for us.
We have seen the equation x squared plus 1 is equals to 0, or x squared is equals to -1 has no real roots. For the moment, let us not worry too much about this. Instead, we'll write I for for root of -1. We could then say that x squared plus 1 is equals to 0 has two roots, namely x is equals to plus or minus I. Yeah.
Semakula, you have muted. Can you open the mic and continue, please? You stopped somewhere.
So I read everything.
No, you stopped somewhere of, we could then say that, start from there.
So I start from where?
We could then say that is, I think, the second line, third line.
We could then say that x squared plus 1 is equals to 0 has two roots, namely x is equals to plus or minus I. Historically, this is how the subject developed. The 16th century mathematician Carando and Bombelli started to use symbols for square roots of negative numbers, even though they knew they were not real numbers. Later, Descartes started to call these imaginary numbers. Then in the 18th century, the Swiss mathematician introduced the symbol I for root of -1.
Thank you very much. I think we have failed to control ourselves because I don't see your mics muted. Everyone comes in with open mics. and then you start even making noise. I wouldn't have wanted it to close all your mics because I want to hear from you. But let us behave. And when you come in, please stay silent so that we can hear from ourselves, from each other, from one another. Thank you, Semakula, for that. The main bit that I wanted here in how we are dissolved, in how the subject grew, is a little bit of that history. I picked this text from Backhouse 1. If you went to Backhouse 1, you will find those words exactly. That is where I picked them. I haven't, they are not my words. Those are words of Backhouse. So we have seen some of this coming, and the mathematicians that came before us had the issues with the square root of a negative number. All along, we have said we don't know the square root of the negative number. And they also had those issues. And we came in and said the square root of a negative number is not real. Indeed, it isn't. Now, we would stop those mathematicians. We would stop there. Like we are also...
Let me see the timetable, please.
May I mute everyone? Is that what you prefer?
No.
But what should I do because you are not us?
Master, let others, I think, behave.
Okay, as they come in, I think we have issues there. Let us mute for a moment, then we shall unmute later, just for a short while. Okay. Hoping you can hear me because I don't want to, I have muted just briefly. We have just been saying that those mathematicians who came before us also had issues with the square root of a negative number, and they said this is not real. We have also all along been saying the square root of a negative number is not real. And usually, whenever we would meet this, we would stop because we didn't know what to do. But at our age, we shall find out that now we need to continue. Even when we don't know, we need to continue with this mathematics, with the square roots of negative numbers. We shall need them for us to be able to continue with our study. So here we are, and we are saying what mathematicians have done, those who have come before us, have just said, let us take I to be the square root of -1. In those cases where they have taken I to be the square root of -1, that would solve the other issues. Why? Because they are looking at when I have I squared, then I squared will be actually the -1. So that I is the square root of -1. Now, what happens if I want the square root of a number like 4, -4? All of us know very well that -4 becomes the -1 times the 4. And so if I want the square root of -4, then I'll get the square root of -1, and I multiply it with the square root of 4. The square root of 4, as we know, is a plus or minus 2, and then the square root of -1, which is I. In the same way, by the way, the square root of -1 can be taken to be plus or minus I, because it is the I and the square root of 1. Okay, so we can take it to be plus or minus I. And in the same way, here, the square root of negative 4 is the square root of 4 and the square root of negative 1, which becomes plus or minus 2. That then solves many of our problems that we have come up with here in our work. But before we continue, let me just ask you, having now shared a little bit of this, can you please go ahead and now get me the square root of negative 16? And like I have requested, can I have Juliet and Shafiq close their videos? Please do close the videos so that we shall allow you to open the videos later on. But for now, can you close them so that we save on our data? Okay, what is the square root of negative 16? What is the square root of negative 16? You can see in the chat. Okay, I thought someone was giving me an answer. Someone has a question. I can open for you the mics so that you can talk to me. Okay, I have answers in the chat. Thank you very much, Alesso, Lydia. Thank you, Ozie. And who else? Anna. Thank you. I have values there for the square root of negative 16. And for other people, yes, I have values from an Honesty. I have values from Galaxy. I said we rename so that I can have the names. I know all of you can rename. Webundu, Lindsay, thank you. I have Grace, thank you very much. Then someone I can open so that you can still talk to me, no problem. Marvin, thank you. Joan Provia, anesthesiologist, to Ishime, thank you very much. Okay, I have Lukenge Deris, Asi Gloria, Mosh, Igiraneza, Lori, Ernest again, Malimbo Juliet, Akicha, Ronald. I have all responses from those people. Nangosha, Kabole, thank you very much. I can now open your mics so that those who want to speak to me, please use the hand up so that you can speak to us. But after speaking, you close the mic. That is the issue with at least for us, we are there. We shouldn't behave like we can't handle this. We can handle. Thank you very much. Okay, so we can see that the square root of negative 16 from your work, the square root of, from the answers that I've seen, the square root of negative 16 is actually the square root of 16 and also the square root of negative 1. And this will give us plus all the minus 4i. In the same way, when you square 4i, you should be able to square the 4. If you square 4i, you should be able to square the 4. And again, square. Pretty, please explain what you are not getting and wish to know where your issue is. Pretty. You can open your mic and let me know what your issue is. Please let us behave. I know there are very many things that you can do, but let us behave. I find it challenging to take the whole lesson just trying to get your attention. That is not good. Someone is annotating, another is doing the other. Please let us behave. Adi and the rest. Okay, I said that if you have an issue, please put up your hand. I saw an issue with who? Do I remember the chat? With Pretty. Pretty, what is it that you're not getting? Are you well connected? Do you have are you in a good place with network? Please check some of those ones, and I'm sure you will get to us. Okay? Okay, so I was saying in the same way, if I gave you, for example, 5i, and I told you to square this, I would expect that you are very comfortable that you would square the 5, and again, you would square the I. You would square, there's an issue with this. You would square the 5, and again, you would square the I. And this squaring of 5 would give you 25. And of course, the squaring of I would give you -1. So that when you square 5i, you come up with -25 and others. So as you get comfortable with finding the square root, please also get comfortable with squaring. Now, what is our I? This I of ours, which we have said is the square root of -1, is what we take. Oh, my body is not very good. I wonder what the problem is. I write and I don't see what I've written, but we shall try. This square root of -1, which is the I, is what we have called the imaginary number I. That I is the imaginary number. It is not real, like we have already said. And now we are saying it is the imaginary number. So when we think about these imaginary numbers, these are not real, but that is our I, which I is coming from that history that you are getting there, that it is from the great mathematicians who have come before us, and they are saying when we have issues with the square root of -1, we can still go ahead and say it is not real, but let us take it to be I. And we are going to use this I. Those of you who have other books, there are some books that you find using the small j, but most books use I for the square root of -1. Okay, then we can continue now and say, if we know that I is the imaginary number that is standing in for the square root of -1, we can get square roots for all negative numbers. And we can also square these imaginary numbers and get there. However, what else do we need to know? Just a minute as I get my page. What else do we need to know? Just a minute as I organize my board for me to be able to communicate better. Okay, I hope that is now going to be better. So what else did I want to say? I was saying that then when we have a number like 4i, if we have a number like 4i, what does that mean? The 4 is a real number, the I is an imaginary number. So the number 4i is all going to be imaginary. But we are saying this is imaginary and we are taking I as our imaginary number. So the whole 4i is imaginary. And if this is the case, then we are going to say our whole 4i is an imaginary number. In general, what do I want to say generally? In general, for all numbers of the nature bi, where b is real and I is the imaginary number and I imaginary. For all of those numbers in the form bi, we are still going to call, or should I say, and I is the square root of -1. I think that is the better bit. If we take I to be the square root of -1, and I is the square root of -1, all numbers of the form bi, we are going to call them imaginary numbers. Now, this takes us to something very great. So all numbers of the form a plus bi, all numbers of that form, where a and b are real, where a and b are real numbers, and I is the square root of -1, I is the square root of -1, we are going to call all those numbers complex numbers. So this brings us to our topic today when we say complex numbers. So for all, what are the nature of complex numbers? Complex numbers are all those numbers of the form a plus bi, where a and b are real. Complex numbers are all numbers of the form a plus bi, where a and b are real. You can have them, I see the book many times writing it that way, where a and b are real numbers, and I is the square root of -1. So all numbers of the form a plus ib are going to be called complex numbers. So today we want to discuss complex numbers and what is important now for us when we come to complex numbers. Just a minute. Just a minute. I am taking a small thing here. Okay, I'm almost there. Just your patience. Okay. Okay. This is what I wanted. This is our topic today. complex numbers. Our topic today, complex numbers. And we have seen what complex numbers look like. Now, what are those things that we may need? Do you still get me, please? May I get someone to unmute so that I understand?
Yes.
Oh, thank you. So we can continue. What do we need to master with complex numbers? There are a few things that we may need to take a note of. One, note. What is the first note? One of the notes is that, yes, Zabera, thank you for that feedback. So one of the notes is that if I have a complex number Z, and Z is the complex number, such that if I have a complex number Z, so if Z is my complex number, and this is A plus IB, then you will notice that the real part of Z, the real part of Z, of my complex number Z, which we denote. So the real part of my complex number Z, which is denoted as real Z, to mean the real part of Z is the A. Our A is the real part of Z, and this is what we take to be a real part for Z. Okay? Then again, we have also another part of the complex number, which part we are calling the imaginary part. So what is the imaginary part of our complex number Z? The imaginary part of our complex number Z, the imaginary part of our complex number Z, which we denote as imaginary Z. So denoted imaginary Z, the imaginary part of Z is now the B. So the real part of our complex number Z is the A, and the imaginary part of our complex number is the B. The I is not part of the imaginary part, but it is the one that is showing us that B is the imaginary part of our complex number. So that is very important for you to take a note of. Now, it is also important for you to notice that if two complex numbers are equal, then their real parts are equal, and also their imaginary parts are equal. This is our first note, but now our second note is that if two complex numbers are equal, then their real parts are equal and their imaginary parts are equal. Semakula have said that when you have a complex number Z, the complex number will have a real part and the complex number will have an imaginary part. So if I have a complex number X plus IY, what you will notice is that for X plus IY, this part here is the real part, and then this part here is the imaginary part. That part is imaginary, the other part is real. So that is what you need to take a note of, that when I have a complex number, It has an imaginary part and it has a real part. So when I have Z is A plus IB, then it means that, okay, for Z is the X plus IY, it means that the real part of this complex number X plus IY, which we denote as RE, that complex number. So the real part is the X, and then the imaginary part for that X plus IY, which is shown to us by the fact that it is the I part, that is the Y. That is important for you to take note of. Semacula. Now, what is the second note that I want? Just a minute here. I hope you can see my screen. The second note that I want comes from your Sadler. Those of you who have Sadler, you can see those small things that I want you to take a note of. What is it that I wanted? I wanted this small thing here. Sorry. I wanted this small thing here. Give me a minute. Okay. I think finally I'm there. What did I say? I said that when two complex numbers are equal, then what? Then their real parts will be equal. And then also their imaginary parts will be equal. That's what I said. Two complex numbers are equal if and only if the real parts are equal and their imaginary parts are equal. That is my second note there. That is my second note. That two complex numbers are equal if the real parts are equal and if the imaginary parts are equal. Two complex numbers are equal if the real parts are equal and if the imaginary parts are equal. I hope you can see my second note there. So when I have, what is it? If I have two complex numbers and I say A plus IB is my one complex number and this is equal to P plus QI, then I expect, what do I expect? I expect that this means that the A and P will be equal. The real parts of the complex numbers are equal, and also, and the B and the Q will also be equal. The imaginary parts of these complex numbers will also be equal. So whenever we have two complex numbers equal, then you know that their real parts are equal, and then you know that their imaginary parts are equal. This helps us many times when we are solving a number of equations, that we equate the complex numbers and we equate their real parts and we equate their imaginary parts. Okay? That is the second note that I would want you to take note of. Then what is another thing that I would want you to take a note of? The other thing that I want you to get note of is that we can always add and we can always subtract these real, these complex numbers. We can also multiply by a scalar, and we can also multiply the complex numbers. We can also we can multiply the complex numbers, we can divide. So we can manipulate complex numbers. But one small thing that I wanted you to take a note of, I think that should be my third note, if I said so. Let this be my third note. What should I say about when you are adding or subtracting complex numbers, during addition or subtraction of complex numbers, we add and subtract or subtract their imaginary parts. So complex numbers are added and also subtracted by adding or subtracting their real parts and also their imaginary parts. That is what I would want you to take note of. If I may ask you, are you seeing my screen?
Yes, sir.
Very good.
Yeah.
If it is still visible. So I am taking my third whatever there, third note there that the complex numbers are added or subtracted by adding or subtracting their real parts and also their imaginary parts. So what I want you to take note here is that if I gave you two complex numbers to add, this time let me give a very simple one. That if you have 2 plus if you have 2 plus 3i, that is one complex number. And to this, you have to add another complex number, -1 plus I, or 3i. Let me not use 3 again. -1 plus 2i. So if you want to add those two, what do you get? I am saying add the real parts. Take the 2 and add it to -1. That is real. And I am saying also add the imaginary parts. Take the 3 and add it to 2. Those are imaginary. The 3, add it to 2. Those are imaginary parts. So what are you going to get finally? When you add 2 and -1, that is a +1. And when you add the 3 and the 2, that is a 5i. So those are, so you add it ordinarily, it is ordinary addition, and it is also ordinary subtraction whenever it is. Thank you, Ozzy. I can see you added them already. Thank you, Ozzy. But please, I think it is not 2 if we are adding -1. I think you can check that. What more? You do the same when it comes to multiplying with a scalar. You will open brackets ordinary opening of brackets. If I say take 2 and multiply it by 3, take 2 and multiply it by 3 minus 2i. Ivan, please do not annotate. This will give me the multiplication of opening of brackets that is ordinary. 2 times 3, which is 6, minus 2 times the 2i, which is actually 4i. So it is ordinary multiplication. And also you can multiply the complex numbers. We are going to get there, multiplying the complex numbers. Thank you, Benjamin, for multiplying by a scalar very fast. Benjamin is already there. There are these people who love to see their videos. Can you please mute those videos? We shall be glad because you will reduce on the data that we are using. Please do not use the videos. I will give you a chance, an opportunity to put on the videos. Okay, those are the many small notes that I may need. Other than that, I want you to take a note of the definition, a simple definition. And this is defining a conjugate. I want you to Is there someone who can define for me a conjugate? Maybe you have already defined it. Please guide us. What is a complex conjugate? I think someone can define it for us. What is a complex conjugate? Can someone define for us a complex conjugate? Please go ahead, open your mic and define the conjugate for us. Yes, are you ready? Anyone there? Ozzy?
A conjugate of a complex is like a reverse of that complex. For example, if it is 2 plus 5i, then it becomes 2 minus 5i.
Thank you very much. The complex conjugate, which we denote with there are a few questions. I have seen them, though I'm still trying to figure out what exactly is disturbing you. Not that I haven't seen. The conjugate, let me see what Sadler has here. We can pick it from Sadler. What is Sadler saying? Okay, I can pick this and we can read it here. What is Sadler saying? Sadler is saying, someone who is ready to read for us. If you are seeing someone who is ready to read for us, please. Did I get that?
The complex conjugate of Z is equal to A plus IB is A minus IB and is denoted by Z star. It follows that the product of Z times Z star is therefore a wholly real number since...
Sorry, I picked that line up to there. Not that I needed all of it, but I think I needed, no, I didn't need actually this second part. I would have picked just one part. I didn't need everything. I just needed the conjugate. The conjugate for A plus IB is the A minus IB, and it is denoted. So if my complex number is Z, like we have been using, Z is one of those common ones that we shall use. If it is Z, and it is the A plus IB, then it follows that the conjugate is denoted with that star, and it is the A minus IB. So you simply change the sign. The sign, if the sign, these two are conjugates of one another. If I say that P minus IQ is the complex number, and I call this W, then the conjugate of W now becomes the plus. So you don't say it is the negative of this, which becomes the plus. So the two are conjugates of one another, of each other. So if the plus is the number, the conjugate is the minus. If the minus is the number, the complex number, then the conjugate is the plus. And so we can comfortably call the numbers conjugates because they are complex conjugates of each other. Okay? So that gives us the conjugate. So I want you to get used to those few definitions. However, like the other statement was saying, what was the statement? The statement was saying that what was the statement saying? The statement was saying that when we come to multiply the two conjugates, if I took Z to be my A plus IB as it is here, and then I multiply it by the conjugate, the Z conjugate, then it means that I will have A plus IB multiplied by the conjugate, which is the A minus IB. And this will mean that it is sort of a difference of two squares because you have already been there. So what are you getting? You get a squared minus the IB squared. So the A is going to remain squared and the I will be squared, the minus, sorry. And the I will be squared and the B as well will be squared. And so finally, what comes out of this? I'll have the A squared, yes. But what do you get when you square I? What is I squared?
-1.
-1. I squared will give us -1 into B squared. And all of us will agree that the minus will finally give us A squared plus B squared. Now, the statement that he was reading for us, I'm sorry I didn't get his name. Was he Benjamin? I don't even remember. Was that when you have...
Benjamin.
It was Benjamin. Oh,
yes, sir.
Thank you. The statement, Benjamin, which you were reading that I had not captured completely was that when you obtain the product of the complex number Z and its conjugate, the value that you are going to get is going to be wholly, there was that statement, wholly real. So you will notice that the value that you get is not in any way complex or imaginary, but all of it is real. I see Nangosha, and you had already got that, and I thank you for that. And I can see okay. I think that's definitely that conversation there in the chat is okay. It doesn't require me to respond to anything. Some people helped to respond to some issues that others had, but that is what we have. So when you multiply by the complex conjugate, when you add these conjugates again, you will get something that is wholly real. When you subtract, you get something that is imaginary, and so on and so forth. But like we have said, you don't have to bother so much about what you're going to get, because you can subtract and get the result. You can multiply and get the result. There is nothing that is special there. May I then say, let us have some simple manipulations of our work. Manipulation, we can manipulate of our complex numbers, some simple manipulations. Can we manipulate? Do a few numbers here and there, add, subtract, and then see if we can. Can we manipulate? That's what I want us to try out. Okay, if you are ready, we can go ahead and try out a few things here. Okay, hopefully you are ready. I want to have just a simple thing. Just a minute. Just a minute. Just a minute. And we shall be there. I'm trying to get my work as Okay. Okay. Manipulation of complex numbers. Just a minute here. Manipulation of complex numbers. Some manipulation of complex numbers here. Okay, I think finally I'm there. Manipulation of complex numbers. And we see how to manipulate the complex numbers here. And we see, okay. Manipulation of complex numbers. I want us to use examples. Those of you who have Understanding Pure Math by Sadler, can you please open page 461? If you have Understanding Pure Math by Sadler, please go to page 461. There's an example there, which is the example 11 in the book. May I know if there's anybody who is there in your book, but we can share. Those who do not have the book, I can give you. Is someone there?
Yes, sir.
Good. Can you read for us the example? What does it say?
Add open brackets 4 minus 2i and open brackets 3 plus 7i.
Very good. Thank you. Who is that?
Alvin.
Alvin, thank you very much. I'm thanking you because I'm very grateful that you carried your book. I know there are very many people who have their books and they're not carrying them, and you're using it. On page 461, our example 11 is part A, add, like Alvin has told us. Please let us begin with part A. Please go ahead and add part A here. Please go ahead and add. Are you done? Part A, what is it saying? You are having 4 minus 2i, and to it, you are adding 3 plus 7i. I think there are answers in the chat. I can see the chat giving me values. Okay, very good. Malimbo, Juliet, Ozie, Benjamin, Cliff, Adi, Lindsay, we have already answered the bit of which book? I think we have answered that bit, Lindsay. Asi, Gloria, Faith, Denise. I have answers already. I have answers here already. Any other? Shalom and to Ishimi. Thank you very much. We have agreed, and I think you are using the principle that when this is the so and we are supposed to add, we add the real parts. So someone is going to add 4 to 3. Those are real parts added. And we add also the imaginary parts. The imaginary ones is the -2 and the 7. The -2 and the 7. And I can see someone giving me the answer 7. Very good. And the answer 5i. Thank you very much. Go to part B. Simplify. Please subtract. I'm now looking out for answers to part B. Simplify, and that is subtraction.
2 minus 6i.
Who is that? Can you first?
So it's 2 plus 6i.
I want to hear.
Plus or minus?
It is a plus because we have a negative outside and also a negative inside.
Juliet, Gloria, and who else? Okay, I like that. So what have you done? We are looking at this as what have you done? You have taken the subtraction. 5 minus 3. Is that right? Then you continue. And when you continue, what do you have? You have 4i. And then you are subtracting a -2i. Hope that one else. You have a 4i. And you are subtracting a -2i. So this takes us to the 2 that you talked of. What else did you tell me?
Positive 6i.
Plus 6i. I hope that is clear to you. That is a 2 plus 6i. Thank you very much. Are we there, everyone?
Yes, sir.
Okay. No challenges. I can see those answers, those values from the very many of you. I may not go through one by one, but I see your values, and please, thank you very much. Alesso Lydia, I haven't picked that answer, but I can see Joanne and the others. I think that is good enough.
Part C is 6.
Oh, Alesso is already in part C. I wasn't with her. Part C is find Z plus Z conjugate if Z is 3 minus 7i. Thank you very much, Alesso. And Adi, I think it was Adi, and the rest now. What is, if my Z is 3 minus 7i, then what is the sum? What is Z plus the conjugate? So Z plus the conjugate will give me, someone is telling me that that is 6, but we have seen that it is 3 minus 7i, and we are adding the conjugate, which is 3 plus 7i. And we have already said this is going to be wholly real. And someone is telling me that it is a beautiful 6. That 6 is real. That 6 is real. Thank you. I can see Benjamin. I can see Engineer Jonathan. I like that. Engineer Jonathan. I can see Henry, Sharon, Joanne, Provia. Thank you very much. I can see Ozie and so on. Thank you.
Sir, Engineer Jonathan, correct.
This is Engineer Jonathan. What are you saying?
Is his answer correct, saying 6 plus 0i?
Plus 0i. When you have 0i, what happens there?
Remain with nothing.
0 remains a 0.
0 remains a 0. It is better when you just put 6. But he's still right when he says 0i because he hasn't committed any crime there. Isn't it?
Okay.
He's
Yes.
still correct. He hasn't committed any crime doing that. Okay. We can look at the next example.
Olaba Zoom yentamye kati okudda ku ssomero. Oh,
Please, can
ndi
you,
bulala.
Gloria, can you mute? Because we can now get all that conversation of yours, of how you are tired of the Zoom. Gloria, can you please mute? It is just good manners. I was about to say you are very well behaved, all of you, until Gloria did whatever, misbehaved. Okay, can we have the next example? Someone with a book, can you go ahead and read, but as I also copy from the book here.
The next example says, multiply 2 minus 7i by 3 plus 2i.
Thank you. I can see that is Dr. Andrea. Andreas, I don't know. How do you pronounce your name?
Andreas.
Andreas, Dr. Andreas. Thank you very much, Doctor. And this is what Doctor read to us. Multiply. And what are we multiplying? We are multiplying 2 minus 3i by 3 plus 2i. I'm giving you a minute. Please go ahead and work out. Then I'll come in only if there are a few people who may not move with us. Andreas, I know you have a book, and this is an example in the book, but leave the book and work out on your own. When you are ready, you put up your hand and I'll be able to pick on you. Alesso, Lydia?
Yes.
What value do you get?
I got 20.
20.
Yes.
Rio, you got Rio number 20. Okay.
Yes.
Austin, what value?
6 minus 14i.
6 minus 14i. This is a pies. I don't know. Is that pies? Answer? Pies?
I got 6 plus 14i.
I like that. People are getting different answers, and that is good. It's showing that you are trying wherever you are. Adams?
20 minus 17i.
Beautiful, different answers. Zabella? Zabella, are you there? Unmute and give us your answer. Engineer Jonah?
20 minus 2i.
And finally, Ozier. Okay.
20 minus 17i.
20 minus 17i. I don't know why we are having engineer, someone is talking in your mind. Engineer?
Keep quiet.
Please, you can mute. You can mute. We shall not hear you. What was I saying? I think the answers cannot be, we can't have all the answers correct. There is, of course, one correct answer. It is, the answer is unique. It's one. I want you to check yourself. How have you multiplied? Maybe that is what I should do. But that is positive to me. That is good because it shows that you are following and you're trying out, and it is normal to be challenged as long as you get on your feet and move. When we are multiplying, what happens? We are opening these brackets in the ordinary way. Now someone will say, now, Henry, what is the ordinary way of opening brackets? I may not be able to answer that. But we are opening brackets ordinarily. Please go ahead and open the brackets in an ordinary way. So how do we open our usual opening of brackets? We shall take that 2, and the 2 will multiply the whole 3 plus 2i, and we shall also take the negative 7i, and it will also multiply the whole 3 plus 2i. So go ahead and multiply. When we open brackets, can someone now guide it? Can we move? What is 2 times 3?
6.
That is a beautiful 6. Thank you. Plus. And what is 2 times 2i? Plus what?
4i.
Very good. Then look at the next in the same way. Look at the next in the same way. What is 7i negative times 3?
Negative
21i.
That is negative 21i. And if that is negative 21i, then we have negative 7i into
2i.
negative 21. Thank you very much. Then we have negative 7i into positive 2i, and that will give us
Positive 14i squared.
negative 14i squared. Thank you very much. Thank you.
It is positive 14i.
It is negative.
It's a negative.
It is a negative 14i squared. Is that right? My square is not so clear. I think that is better. Okay, so we are going to have the 6, which is no big deal. Then we can add these two. What is 4i minus 21i? It will be a negative 17i. Then we can have the negative 14 and the I squared. From what we know, the I squared is another negative 1. Meaning negative 14 and negative 1 is going to give us positive 14. Positive 14. Then we shall take away 17i. So this will give us 20 minus 17i. So those of you who got something different, I want to think that you are with us now. Please let me know if there's any challenge. Hi, Kiriza Aiden. Thank you for that answer. Engineer, you want to try another? No problem. I'm going to give you another. And who else there? Can see Provia. I can see Joanne and others. Thank you very much for the trial. And we can now move on. You can check yourself how you are simplifying to get the complex number that we need. Good. What do we have in the next example? The next example is not exactly multiplication. It is division. I don't know whether you feel that it's very important for me to give you another multiplication example. Is it very important? Or we can go and now handle the division.
Let's handle the division.
We handle the division because somehow as we divide, we are still going to multiply. Now, the division. Let me give a little bit of guidance before you go there. When we are dividing the complex numbers, If I gave you 2 plus I, and I told you to divide by 3 minus 2I, what do you expect during the division? Our challenge is having the complex number as a divisor. So what do we do? What we do is we multiply. We try and drive out the complex numbers in the divisor. So the divisor is our guidance. So get that divisor and make it real. How do I make it real? I'll multiply by the conjugate.
Conjugate.
Very good. And that is 3 plus 2i.
Plus 2i.
Because I know that it is going to make my divisor real. But of course, from our usual math, I know that I cannot just multiply by the conjugate in the divisor and keep with, I will have changed the meaning. So what do? I do the same for the divisor and also for the dividend. So you will also take the 3 plus 2i to the numerator. The rest is ordinary. Multiply the normal way. You're going to have the 3 by 2, which is giving us 6. You are going to have the I by 2i. Because I know they are going to give us real numbers, I can begin with that, which gives me 2i squared. 2i squared. Then I'll have the 2 by the 2i, which is giving me the 4i, and I'll also have the I by 3, this one here, which gives me the 3i. Thank you. Thank you very much. Continue. What happens when we continue? When we continue, we shall have the divisor, which is difference of 2 squares, and that will be 3 squared minus 2i, which is also squared. 3 squared minus 2i squared. So whatever you will come up with in the numerator, in the first place, I know very well that from my I squared, I'm going to get -1, then multiply it by 2, which will finally give me negative. Huh? What does it give to me? It will give me 6 minus 2.
2.
And then the other one is no problem. 7i. And then the numerator, which is difference of 2 squares, for it gives me 9 minus 4i, which is again squared. Good. Go ahead and simplify further. You have 4 plus 7i.
Divide by 13.
Divide by 13. I like that. 9 plus 4. That becomes a plus. And that is where this guy is getting 13. So we shall have 4 plus 7i divided by 13. I can leave it like that. Or if not, I can go ahead to have 4 over 13, the real part. And then I'll have also the imaginary part, 7 over 13. But indicate this is imaginary. Thank you very much. So what did we say? We said all that we have said and we have gone through it. And I want to say we can handle. I want to say we can handle. Now you are handling alone. Example 12, multiply. Oh, example 12 is multiply. I should give example 13, which is divide. After giving that guidance there, I now go ahead and give the example 13, which is divide. Okay. Someone is ready. Please tell me you are ready.
So we are ready.
Ready.
Good. Good. Now I'm coming with the example. Allow me to copy it from here. Then I'll give the example 13. Well, good. Go ahead. This is the example. Divide by that by that. That is our example 13.
Sir.
Yes, please. Who was that? I didn't take note of who it was. Yes, please.
Austin.
Yes, Austin.
So I have -1.
You already have the answer?
Yes.
Austin, that is beautiful. It's nice to be fast.
-1.
Let me give a minute to the friends to also finish.
Okay, sir.
Just a minute. And I can see 2 hands up. Please, when you finish, join the hands up so that I can know who has finished. I can.
-1/10 plus 17. Baki daudi haraka.
I see 10 hands up. Some people don't know how to raise their hands. Want to see 60 hands up. Now 15, thank you. Now I can see 16, good. Please raise your hands. 19, 21. Oh, everyone has finished?
Yes.
So am I free to just choose at random?
Yes.
Are you sure?
Yes.
I see 27 people now.
Yes.
Thank you very much. Let me see engineer. Engineer, you are saying engineer now, this is not Jonah. Engineer, please give me your answer, but add your name also to the engineer, to your title.
-1 plus 17 I out of 10.
-1 plus 17 I out of 10. Who is this one? Engineer is who?
This is Engineer Abigail.
Abigail, glad to hear from you. May I hear from Ronald? Elijah, you have opened your mic. May I hear from Elijah?
-1 plus 17 I over 10.
Good. Did I want Ronald? Okay, let me hear from Ronald.
-1 plus 17 I over 10.
Thank you very much. So, can we say everyone is there? If you have a challenge,
Yes.
now many people have opened their mics. Please close. Close so that we don't get feedback. Good. Brian, you haven't closed. Austin Doctor, you have closed. The good guy. Brian, close. Thank you. Joanne is Joanne. Thank you. Now, may I say, let us all put down our hands and let me see hands of only those ones who are challenged. Let me see hands up of only those ones who are challenged. Otherwise, many of us have gone through the same, have gone through it comfortably. Oppo, do you have any challenge? To Isime, open and take to us. Any challenge to Isime?
Yes, teacher.
Yes, please. What is it?
I don't have a challenge in mathematics and arts.
I haven't heard. You don't have?
I don't have like I have worked out the number, but I'm kind of requesting if you if there is an order of writing the question, like the answer, presenting the answer.
Oh, your question is on presentation. Someone who has presented -1 plus 17i, was it 17i? Out of 10. That one is okay. If someone has said -1 out of 10 plus 17 out of 10, that one is okay. If someone has said 1 out of 10 and has said -1 plus 17i, that one is okay. At a time when they ask you for the real and imaginary parts of the complex number, only then is when you will need this here. That is when you need that. If they ask for the imaginary and the real part of the number, that's when you need that. But otherwise, all of those presentations are okay. Hashim, please. Your hand is up. Something that you want to comment? Please comment. Hashim, open your mic and make your comment. And Oppo, open your mic and make your comment.
Yes, excuse me, sir.
Yes, please. Can you raise the voice a little?
I wanted to ask. Yes, I got this answer, but what if it's in decimal places?
I can't hear you. Can you raise your voice a little bit?
Yeah, I wanted to ask, yes, I got this answer, but what if I put it in decimal places that I put -1?
Decimal places. Like you give what? Tell me what you give.
Like -0.1 plus 1.7i.
-0.1. No. I want to scroll. My screen is not scrolling. Okay, I'm there. You want to give -0.1 plus 1.7i. Oppo, can you tell me what you think? If you gave it that way, do you think that is correct?
I think it is correct because sometimes say like give it in a form like a plus ib, like in that form without putting like out of something.
Those are the same things, Oppo. It is correct. Thank you. I have no comment. I have no objection. It's correct. Any other? Any other? Hashim had opened the mic. I don't know whether it's still there. Hashim, not there. Esther?
Master.
Oh, Hashim, yes. Hashim, I can't hear you. Esther?
Excuse me, sir.
Yes, please.
I was asking whether is it a math that we are supposed to start with a real number, not an imaginary number.
I like that. It's not a must, but it is the common way of presentation. For example, if I knew your name, I would say, Esther, what is your surname? Esther, what is your surname?
Chimbugwe Esther.
Now, if I know your name as Esther, I can call you Esther Chimbugwe and I can call you Chimbugwe Esther. But there is that common one that you use. And I think that is the Chimbugwe. I think you use the Chimbugwe Esther. There is that common. So you will notice that in our presentation, the common presentation is the real first, then the imaginary. But it doesn't mean that the other makes it wrong. It doesn't make it wrong, though this is the common thing. So whenever you are in any books, you will find that the presentation is of the real part and then the imaginary finally. Provia?
Thank you, sir.
Welcome.
What if I separate the real number from the imaginary number? I write it as negative 1 out of 10 plus 17i out of 10.
17i. Your problem is to have 17i, then out of 10. Is that the issue?
No, I'm saying what if I separate the answer, the good imaginary number from the
real? We have that already. Don't we have it?
Okay.
My screen has hidden it. I circled it. Are you seeing that answer?
Yes.
Isn't that what you are talking about?
Yes.
Hey, I have no problem. That is very, very fine. And finally, is that finally? Can we have, who are we having? Can we have, do you still have my screen?
Yeah.
Okay. Can we have Galaxy? I don't know who Galaxy is. I told you to rename. You are above the level of just giving the phone type. Galaxy A10, who is that? Please rename, but go ahead and say what you want to say. Galaxy, please say what you want to say. Galaxy, are you there? Galaxy, are you there? Okay, if Galaxy is not there, then we can have another example, and then you will try and try and try. Okay. What do we have for the other example? The next example requires that we find the square root. I hope. The next example requires that we find the square root. Okay, where is the example? That is our example. Find the square roots of 3 plus 4i. Find the square roots of 3 plus 4i. Just to give a simple hint, can you work out with this kind of thing that let a plus ib be the square root of 3 plus 4i. And you go ahead and find a and b. And then you give me the square root. I'm giving you a few minutes, and you will then you put up your hand just to guide me that you are through. Shall continue.
Just stop with game developers outside the companies. A last-minute email went out to top engineers within Google working on Stadia, informing them of the termination of the service a mere 3 hours before the public did. But that's how Google does things, right? Try something quietly, slowly fix. With YouTube gaming to promote this thing, let alone stream onto it. One of Twitch's best features over Google Live is the ability to interact with your audience. Stadia not only promise features that will fight this, but it have the ability to completely demolish it. The user base of hardcore casual FBI.
Yes, I can see. Engineer Abby lost. Engineer Abby, you can't be lost now. You are an engineer. You can see probably I lost. I'm now lost. Emma, you people be serious. Let's be serious. Do not. Next, I can see my screen is black. Tony, do you still have a black screen? Tony, do you still have a black screen? Tony, is Tony still there? You can swipe. You can swipe on your screen. Huh? You can swipe either on the right or on the left. Ah, okay. Someone is saying I ended on the heat. Let's try square both sides. Square both sides and equate. And here I am receiving answers already. You can see to Ishimi is sending the answers. Square both sides and equate and go ahead and look for the values. I hope this time you will not be stranded. Square both sides and equate and go ahead. Square both sides, equate and go ahead. Engineer, I hope I will have, I'll be the engineer now.
Excuse me, teacher.
Yes, please.
Teacher.
Yes, please.
Okay, I squared both sides, and after squaring, I had something like, okay, I made B the subject, and I had something like a raised to power 4 minus 3s
You
squared.
have, wait a little bit. You have
Yes.
squared and you have equated it to 3 plus 4i.
3 plus 4i, yeah.
Then from there?
Yeah, and from there, I had something like s squared
This gives you A squared
plus 2abi
plus 2abi. Yes. 2iab.
and then plus, yeah,
Wait,
2iab.
no.
Yeah.
You can write it the way you want.
Okay.
Don't worry.
iab. Yeah, then plus I squared
I'm
b
disturbing
squared.
you by writing what I want. Let me write what you
Okay.
want. 2abi.
Yeah, then plus
Mm.
plus I squared b squared
Mm.
is equals to 3 plus 4i.
Mm.
Yeah, then after that, okay, since like when we square the I, we get a -1, I had a squared
Mm.
minus b squared
Mm.
plus 2abi
Mm.
is equals to 3 plus 4i.
Mm.
And then from there, I compared, like I used comparison and I had a squared minus b squared
Mm.
is equals to 3.
Mm.
And then also I had 2ab is equals to 4.
Beautiful.
Yeah. Then after that, I made like b the subject and I had b is equals to 2 out of a. Yeah, then after that I substituted for that in that first equation where there is a squared minus 2. Okay, yeah, is equals to 3.
Good.
Yeah, then after that, I multiplied all through by a squared and I had a raised to power 4. A raised to power 4 minus 3a squared
Mm. Minus 3a squared minus 4.
Yeah, minus 4
Mm.
is equals to 0. Then from there I used I used like the normal way of solving like a quadratic equation.
Mm. The
Yes,
factors,
so I had like
the factors of -4 are
okay, I
-4
used
and
I used 1 and 4.
1. So a squared is
Yeah.
4, squared is
And then
-1.
yeah. Yeah, then from there I solved it. So if a squared is equals to 4, and then also a squared is equals to -1.
Mm.
Then I took the roots on both sides, so that means a is equals to plus or minus 2.
Mm.
And then also a is equals to, okay, the root of -1 is I, plus or minus I.
Mm.
Yeah, then from there to find the value of b, we had b now to be equals to 2 out of a. So since when a is equals to +2, our b is going to be 2 out of 2, which is equals to 1. And then also
So a is
when
2.
yeah, when a is
That's
2,
b.
b
B is 2 over
is
2.
yeah, it's 2 over 2, which is 1.
Yes, a
Yeah.
is
And then
-2.
also when a is -2, our b is equals to -1.
Our b is 2 over -2. Is it like that?
Yeah, which is equals to negative 1.
Negative 1.
Yeah.
So from this one,
Negative 1.
we are getting
Yeah.
A plus BI. And from this one, we are getting negative 2 plus minus I.
Okay, there is 2 plus I, then also, minus I.
So that is why
Then
we are
also,
having the 2 plus
okay,
I,
that is where I was able to stop.
all the negative 2 minus I. Then what did you do about this
Can you
part?
hear me?
I can hear you. What did you do about this part? Rita, you are lost. Okay. Now I can hear.
Okay, I was saying that I think I was only able to find those 2 values.
What did you do after getting? How did you use this other part?
Okay, the part for the I am not so sure.
This one here. How did you use this other part?
I did not choose that other part. I am not so sure about it.
Why did you not use it?
Okay, I'm not so sure on how to manipulate that
say,
one, but
you can still say 2 out of negative I or 2 out of I, etc. But anyway, I want to say that yes, recall that when we are doing our work, we take from here where you say let this part here, let A plus I be equal to the other. Here you are assuming this complex number to be equal to. So this is a complex number. And if this is a complex number, what is it that I would want you to take a note? I want you to take a note of the fact that, which fact? The fact that A and the B are real. That's very important. So the moment you come down here and you find the A, which is I, not real, then you reject it. Because from the original thing we were saying, if it is a complex number, the A and the B are real. So this one that is giving you an A that is not real, reject it. So you're going to end up with those 2 answers. And I've seen people with those nice answers, and I congratulate you. And even those ones who did not have the very beautiful answers, I know they have been following, and I appreciate you. Thank you. Halima, you put up your hand at a certain time when I wanted to see hands of those who had finished. I hope you had finished. You have a question. Halima? Okay.
I just finished.
You have just finished, but there's a time
No,
when
I know. When I put up the hand, I just finished.
Then you are finished then.
Yes.
Cool. Thank you very much.
Thank you, sister.
Okay. You can see that we can get there. I don't know whether people are getting energized or they think that things are tougher. No, they are not tough. This is algebra, multiplication, addition, division, this ordinary stuff. I'm sure everyone. Do we have any questions? Anyone who wants to make a compliment or a supplement? Nobody. Halima, put down your hand. You keep making me think that you have something. Put down your hand, please. Thank you very much, Halima. Okay, if there are no other issues, then we can continue. We can continue. Let me see. How many minutes do we have? Can someone be our timer? We have about 10 minutes to reach 4. Our lesson is 2 to 4, not so?
Yes.
Yeah. We have about 10 minutes. 10 minutes. Let's use them, no problem.
Excuse me, sir.
Yes, please.
This is Derek. And I'm requesting you
Derek, yes, Derek.
I'm requesting you to re-explain for me that last part, that last example.
And you are requesting me to do what?
To re-explain for me that last example.
Excuse me, sir. Excuse me, sir.
Yes. Emma?
I was requesting, may you just help and repeat this example that the last one, for exam 14.
Emma, what did you want?
May you help me and repeat this last example 14?
Emma, this is what we have said. I even don't know whether we can say it together again. We said can we first handle? Okay, you say what you want to say.
Okay, teacher, I was asking, I've understood that thing, but this part of the quadratic, how you've gotten the unknown, like the answer. I don't know how you've gotten it. The one with the power 4, b power 4, then minus, that unknown.
You are far better than some of us who are still at the beginning. So you relax there and just have your dance. Hannah. Okay. I'm saying that take the square root of 3 plus 4i to be a plus ib. When you do so, what happens? When you do so, you square both sides. And that is where Ruth, was it Ruth? Rita. That's where Rita said, you know what? When I square both sides, I am getting, what did Rita get? Do you remember? I am getting a plus ib squared. And I'm also getting, when I square, this is square root. So Rita squared this square root and got 3 plus 4i. The square root disappeared. So she got 3 plus 4i. This here is 3 plus 4i that she got. So after having got 3 plus 4i, she went on. And when she went on, she squared the left-hand side and ended up getting a squared minus b squared plus 2abi after simplifying. And she's still equating to 3 plus 4i. Here, 3 plus 4i. And when she does that, she equates the real part. We had that as a note somewhere. Was that note 2? Where we said when the complex numbers are equal, the real parts are equal and the imaginary parts are equal. She equated the real parts and she equated the imaginary parts, so came up with the 2 equations, which she chose to solve simultaneously. She came up with 2 equations and chose to solve the 2 equations simultaneously. Now, each one of us can solve in their own language or in their own way. She got rid of B. She got B in terms of A, substituted in another equation and got rid of B and realized the equation was quadratic and then solved the quadratic equation. Now this is where Anna is saying now quadratic equation. Anna, handle the quadratic in your own way because you can use the bulldozer, you can use any other. But this is using factorization. The factors of -4 which add up to -3 and -4 and 1. So they are the factors that we have used here to produce a squared minus 4 and also to produce a squared plus 1, which is equal to 0. Got the 2 values, a squared as 4 and also a squared as -1. Now, a squared as -1 gives an imaginary number, which we are rejecting, saying our a and b, which are coming from the complex number, are real. Then we rejected that one and we went with A is 4, which gave us plus or minus 2i, and we substituted somewhere in values and got the B. And since our answer was A plus BI, we connected them and got our final answer. I wonder whether that is whether it is not making sense now. Well, I should now relax and say we continue a little bit. Oh, we are using our time, I think. Okay. Someone is saying I am speaking, but he's not listening. Why don't you listen? Or you are not hearing? Maybe. Oh, it's now clear. Okay. I can no. I'm still having a problem with someone there. With the who is this? With what? With it is something. Okay. Let me ask, is that okay? The quadratic Hannah, is that Hannah? Quadratic you can handle. Hannah, the quadratic, please handle it.
Excuse me, sir.
Yes, please.
That part of s squared minus 4 over s squared is equals to 3. What if you just let any letter?
It is okay.
Okay.
It is okay, you get there.
And that part of f power 4 confuses a lot.
Yeah, it is okay, you get there.
Okay, sir.
The most important is for you to recognize that it is quadratic. Then if you can say a squared is x, or s squared is m, no problem. You get a quadratic equation and then you solve it.
Okay.
That is great. It is nice to notice that.
Okay, sir.
But as you grow now, you are becoming Kanyamazi. I expect you to be able to handle even when it is not changed. That's why I have not bothered so much to change it. Okay. If there are no other comments, may I say that maybe now you will take screenshots and go ahead and answer a few questions, because I don't see time that will take us to something. Let's stop there and get a few questions. Those of you who have Sadler, because I am sure many you all have it, please go to page 460 what? 463? 463, I think. And then answer. And answer those questions on page 463.
Excuse me, so you have said which page?
Page 463, there's an exercise 18D there. But if you don't have the book, you can take a screenshot here. If you don't have a book, you can take a screenshot here with our book. We have a book here with us. So if you don't have a book, please take a screenshot. I want to see how to get you there. Okay.
So which book are you supposed to use?
I am using Sadler, but you can use any other book that you have and you see complex numbers. But for me, I'm using Sadler.
Okay.
But the complex numbers is not only in Sadler. Okay, can you take that screenshot? It has those numbers, and they can be useful for your exercise. Should I scroll?
Yeah.
Number 1, part C is not seen.
Part what?
Oh.
But you see, I can see Z conjugate, I think.
Okay, I've seen.
You can scroll.
Tell me to scroll.
Okay.
Scroll.
It's fine, so you can scroll.
Be polite, you are talking to a teacher. May you please?
Yes, may you please scroll?
Hey, that is good manners. Let's just say scroll, scroll. No, that's good manners. You can now take a screenshot. I don't know whether I have given you all the numbers. Let me give you from.
You're talking to a teacher.
Are you there now?
Yes, sir.
Guys, scroll finally.
Yes.
Yes, teacher, please scroll.
Okay. I think that is
Please,
the
teacher,
last
you
thing.
can scroll.
No, there are others, but you can
Are
go
you
up.
my scroll?
You can go up to 10. There are other numbers, by the way. I don't know whether you can answer all of them. I don't think you can answer all of them. But it's okay for you to look at them and
Find out.
see how much you can. Or someone wants a soft copy. I'm going to ask Mr. Kazua to share a soft copy with you. A soft copy of the book. Oh my God. Okay. Thank you very much. I want to say what? I want to appreciate you. One for attending. Two is for trying to behave. I can't say you behaved very well, but you tried. Three is for trying what? So thank you very much for trying out the questions, for being attentive and moving with us during the lesson. Thank you very much. I don't want to take you for granted. I am sure if I opened and nobody entered the room, I wouldn't teach. I would not teach anyone. So thank you, and thank you very much. May I request someone to say a word as and we close? I ask someone to close with a prayer. Okay. When I say to say a word, you may say other words. I ask someone to close with a prayer. Anyone ready to give us a closing prayer? Okay, Jonathan, I'm going to mute.
Yes.
Jonathan is ready. Provia, thank you, but let's go with Jonah. I'm going to mute everybody. Then, Jonah, you'll open your mic again. You open your mic again. I'm going to mute everybody. Then you open your mic again and lead us in prayer. Okay, Jonah? Open your mic, please.
Father, for this good time you have given us with our teachers, put it in consideration. Heavenly Father, thank you for the gift of life, the gift of our teachers. Prayed. Amen.
Amen.
Amen. Thank you very much.
Amen.
Grace, it is not only boys. Who led us in the opening prayer? I just looked at who had put the hand up first. Was it a boy who led the opening prayer?
Yes.
No, sorry, I didn't follow that. I just looked at who had put up the hand first. I can see
But they were not.
it is boys only. No, it's not boys only.
Hope
So
you send
we
me.
can end here. Bye-bye. Now you can open your videos. Those of you want it. You can open your videos and say bye-bye. Bye-bye.
Alamanoi.
Hey.
You're speaking in tongues. You're speaking in tongues, man. Hey.
You understand the language?
That is why this coming, man. Yellow man.
Apoyo Matek.
Matek.
You stop your tongues. The Holy Spirit hasn't entered yet.
Let's use English.
Mereka dah okay.
These guys were complaining, the only boys.
Okay, bye-bye.